Hi, let's look at the a full question of the work power energy. Okay, so with that we will look at the tutorial 2 question 10. Okay, this question is about a vehicle being accelerated from rest. So a lot of information you can get from the question. So for example, accelerated from rest. Okay, meaning it starts with 0 speed. And it will go until 14 meters per second over a distance of 110 meters, incline of 1 in 8. So let's look at this one. And it is going up, up the incline, means the vehicle is going from down to up. Okay, so with this we can sketch out a diagram something like this. And what else is given to us? The distance it covers is the 110. So in this way, this is actually the hypotenuse. Okay, the hypotenuse of a right angle triangle. Okay, and the angle itself. Okay, you can get the clue from the incline of 1 in 8. Okay, 1 in 8 incline. It means that sine theta is equals to 1 over 8. Okay, so just now I mentioned about the hypotenuse, right? So you're going to have a hypotenuse. This is 110. Okay, this is your theta. So what is the height? Which means you can find out how high it has reached. Okay, by the time it reached this point. Okay, so sine theta is 1 over 8. And sine theta is what? Opposite over hypotenuse. So opposite is your h, right? H over 110. So in fact, from this equation you can find h. All right. Let me see. H is 1 over 8 of 110. Okay. So let's just keep this in mind. Okay, and then we also need to determine the 2 states. Okay, so naturally when it starts, it should be state 1. Okay, state 1 as it starts, and then as it covers the 110, this will be state 2. Okay, and the other one is we need to determine where is your 0 potential energy. Usually we will set the 0 at one of the states okay, and the 1 at the lower position. So for this case, state 1 is lower than state 2. So this height is your 0 potential energy level. Okay, so it will be very easy for you to find PE2 because you just need to do a MGH. Okay, later on. So let's go part by part first. Okay, find the kinetic energy when the speed is 14 meters per second, which means find the KE here. Translational. So KE translational is simply half mv squared. Okay, half times the vehicle is 1500 kilograms. Okay, 14 square. So this will give you 147,000 joules. Okay. The next one is the rotation. Okay. Rotational energy, KE rotation, also at this point. Okay. So how do you find this? Where do the rotation energy come from? The rotation energy come from the wheels, okay, and the axle. So normally for a vehicle, right, you are going to have 2 axles, okay, and each axle will have 2 wheels. All right. What is given in the question has each axle, okay, has a mass of 120 kilogram. Okay, which means the 2 wheels plus one shaft, this whole thing is 120 kilogram. Okay, okay? And it has a radius of gyration. Okay, if you still remember radius of gyration, 350 mm. So we have to use the meter SI unit. So it's 0.35 meters. Okay, you know that your I is a mk square, right? So I can find the I for each axle. Okay, I for one axle is mk square. Okay, so this is what you should be using, and we have two axles, so we need to multiply by 2. Okay, so for each axle there is one rotational kinetic energy. Okay, so for both axles you are going to multiply by 2. Okay, 2 of what? Half I omega square. Okay, so this is one axle, so 2 times 2, I have the total rotational energy for the whole vehicle. Okay, now I have I already. I need to find out what is W, omega. Okay, how do you find omega? This is the theory here. So imagine your wheel, okay, is going along the surface. Okay, your wheel is rotating here. Okay, so the center of the wheel is going at 14 meter per second. Okay, that's your V, right? That's your velocity. So if you imagine yourself, okay, if you imagine yourself, you place yourself at the center of the wheel. Okay, what do you see? Instead of seeing yourself moving in this direction, right, you are actually only seeing the wheel moving in this direction, rotating. Okay, so we see this because we are standing out. We are a spectator, right, looking at the whole system moving at this direction. But if you put yourself at the center, okay, you are only seeing the wheel turning, okay, in this direction. All right, and this turning is your omega. Okay, and the formula is omega, right, is actually related to this velocity divided by the radius of the wheel. Okay, omega is equals to V over R. So that is how you get your omega for the rotational kinetic energy. Okay, so we're gonna write it all out. Times half I would be this 0.35 square times, okay, omega is V over R. V is 14 radius of the wheel. Okay, the diameter is 800 mm, so the radius will be 400 mm. Okay, convert to meter is 0.4 meters square. Okay, so this is omega square. Okay, so with this you will be able to get 18008 joules. Okay, so total kinetic energy, part C, total KE total is quite straightforward. It's just KE translation plus KE rotation. Okay, which is your 147,000 plus 18008. Okay, 165.01 kilojoules. Okay, the first two terms are in joules, then here you can find in kilojoules. Okay. Okay, part D. Tractive effort required. Tractive effort required. Okay. Tractive effort is basically your engine force. Okay. Okay, how this vehicle managed to go up is purely based on the engine. The engine is providing the force that pushes it up. Okay, so in fact, if you draw the free body diagram, right, there is a force, okay, tractive effort, okay, and there is also a friction that is going against the motion. So this one is your resistance, your friction resistance force. Okay, but of course your engine is going to be bigger than the resistance. That's why overall it still is able to go up. Okay, so we have to take these two into consideration as in where under the term work done. Okay, remember the work done. State 1 plus work done equals to state 2. Okay, now you look at this diagram, then you look at state 1 and state 2. Okay, state 1, what energy does it have? It starts from rest, so there is no KE. Okay, and also state 1, we have decided to use it as the reference line, reference height for zero potential, so there is also no potential energy here. Okay, so in fact your state 1 is 0. 0 plus 0. Okay, work done. Okay, work done, you have 2 because there's one engine force, there's one resistance force. Engine force add to the energy of the vehicle. Resistance force reduces the energy from the vehicle. So this is plus, this is minus. Okay, work done will be force times distance, force times distance. Okay, so in this equation it will be engine times 110 plus and subtract friction times 110. Okay, what does state 2 have? State 2 that's how your part A and B and C will come in. State 2, this is the total KE, is actually total KE at state 2. Okay, so we have KE total over here, this value. Okay, and we also must not forget about potential energy at state 2. Alright, so we need to add in the relevant numbers. Your friction is 200 Newton per ton. Okay, per ton. 1 ton is 1000 kilogram. And how heavy is this? This is 1500. Okay, so the total FR for this vehicle, right, is 1.5 times 200. 1.5 ton. Okay, so 300 Newton of resistance force. So here we will write engine force times 110 minus 300 times 110, okay, equals to you can put 165008. This one still in joules. Don't use this. This is kilojoule. This is not SI unit. This is SI unit. Okay, plus what's the height? MGH. Okay, mass of vehicle is 1005. G is 9.81. H is your 1/8 times 110. Okay. So here the only unknown is your engine force, and you will find Ft to be 3639 Newton. Okay. So again, once again, if you are able to identify this situation, you should be able to form out the terms of each of these energy equation terms. Okay. And last but not least, the question is the power required. What does power required means? Required from who? Correct? Okay, the answer is it required from the engine. Okay, because it is the only one that's doing work. Okay, so if I want to know the power required for engine, power is what? Force times velocity, right? So what force? Must be the engine force, traction force. Okay, which you found out just now, 3639. And the velocity is 14 meters per second. Okay, so here you get your answer in watts. Okay, which will become 50.95 kilowatt. Okay, so this is the full a typical question for this topic of work, power, energy.